crusher Hydroset control napakuvala twala monati mudi rank 58 mudi Hydroset pressure switch or twale about the protection input. Okay, so the other thing for twala sharp of your during the assignment of my peripheral inputs and peripheral outputs, for the inputs to apply the input 6 point, this was a protection input, I think. The ordinary anyway, Hydroset pressure switch is a protection input. So to apply the input 6.4 and the Hydroset pressure switch symbolic table, I think. Yeah, developed as a Hydroset pressure switch. Cool, let's see. Hydroset pressure switch. I think that's what it was, at least. Let's see, it's under protection. Hydroset pressure switch. Where do we talk about the Hydroset pressure switch? Yeah, so this is the Hydroset pressure switch. Otulaitati HP SW. So I just want a symbolic name, because when it comes to the peripheral addressing, I need the input 6.5, I think. Input 6.5, which is the next available address. So insert symbol. No, not there. I need it right about here. Okay, and what we want is this Hydroset pressure switch dash PI, just meaning we're talking about the peripheral input. Okay, so maybe the symbolic comment we can just as well get in a the Kodi memory bit addressing. So Hydroset pressure switch, which is this one, I'm going to assign the same symbolic comment to this one, except this will be peripheral input. Okay, so that's done. So we've taken care of the input today about the Hydroset pressure switch as a protection input. Gamamona, I've gone to input 6.5 because we also have these lower addresses. These were supposed to be just for ordinary inputs, which is to say nothing to do with the protection aspect. Okay, so Hydroset pressure switch to afunyako, then kwa the Hydroset raise na Hydroset lower. So did we have Hydroset raise, Hydroset lower? So these were just ordinary inputs. These two are ordinary inputs. Okay, so we'll go to ordinary input address range, insert symbol, insert symbol again, and then of course we're talking about Hydroset raise now, Hydroset lower. Okay, so Hydroset raise, Hydroset lower, we're looking for these. Okay, symbolic names, then we can paste them there, and then Hydroset raise as peripheral input, and then Hydroset lower as peripheral input, addressing input 1. Or rather input 2.4, then input 2.5. So this takes care of the Hydroset raise, Hydroset lower as inputs. Okay, and then when we talk about the protection inputs, we've got the thermal overload, and then we've also got the earth leakage. Okay, we're going to insert two symbolic names which have to do with the thermal overload and then earth leakage. Okay, for the Hydroset. So these were protection inputs, so we need to go to the memory bit address range of 2.20 something point something range. Okay, so we're looking for 4CE3, and then we're also looking for 4CE2. So 4CE2 and 4CE3. So 4CE2, okay, we're looking for these two here. Okay, which is Hydroset thermal overload and Hydroset earth leakage. Okay, we're going to paste them there. No. We need them there. Let's delete this. Yes, please. And then these are going to be peripheral inputs, okay, like so. And then of course they still have the same symbolic comment, okay, which is to say we're talking about the 4CE2, 4CE3, 4CE3. I think they're in the same order, so 4CE3 and 4CE2. So let's see, 6.4CE3, 4CE2. So we can paste these here. So the only thing we need is now to assign Yadiama physical outputs, okay? So the physical outputs will have the 4CC1 and 4CC2. So these were ordinary outputs, so we need to go to 4CC1 and 4CC2, okay? So which are these two, okay? Hydroset raise control, hydroset lower control. And then these are going to be outputs. So the outputs will assign them starting from here. Insert symbol, okay? We need two of these, okay? And then of course we're saying we need 4CC1 and 4CC2. So 4CC1, these are going to be peripheral outputs, okay? These are peripheral outputs. And then Q5.3, then Q5.4, and then of course the same symbolic comments, okay? So 4CC1, 4CC2, we're going to copy this, and then we're going to attach this here, and then we're going to say peripheral. Okay, this is just peripheral output. Okay, PO. I wasn't even indicating that these were peripheral outputs, but PO just means peripheral outputs. Peripheral means external to the PLC, okay? It's an output which is being controlled external to the PLC, okay? So we've got 4CC1 PO, 4CC2 PO. So we've taken care of 4CC1, we've taken care of 4CC2. 4CD1 is internal to the PLC. It's just for internal control, internal logic processing. And then we're going to have 4CH1, and then we're going to have 4CH2, okay? Then 4CH1 and 4CH2. So 4CH1, 4CH2, these are going to be outputs, okay? So we need two of these. Insert naimbi to aposapo, insert symbol, and then we're saying we need 4CH1, 4CH2. So we're going to copy these, we're going to paste them here, and then of course our favorite PO, okay, just to indicate that actually we're now talking about external control, okay? Then Q5.5 and Q5.6, and then 4CC1, 4CH1, 4CH2. We need the symbolic comments because it's still the same action, okay? Except we're talking about external control. So 4CH1 is a hydroset status faulted indication, and then 4CH2 is hydroset on, okay? So we've taken care of 4CH1, 4CH2, and then the other externally controlled load will be the solenoid valve, SVC, okay? So let's see, we insert symbol, okay? And then what we do have is SVC, okay? We've got SVC dash PO, okay? Dash PO, now dash PO, like so. And then that takes care of the solenoid valve, okay? Pretty much that takes care of all the associated inputs and outputs to do with the hydroset, okay? So now we move on to the vibrators, okay? This is just the crusher vibrator control, and then of course we're going to start with vibrator 1, okay? So where vibrator 1 is concerned, we are talking about the earth leakage protection 4AE2, which is a protection input. So 4AE2 should be right down here. 4AE2. Where did I see that? 4AE2. Oh, should be under protection. So 4AE2 is there. Okay, so we identify that 4AE2 is a protection input, and then 4AE3 is also a protection input. 4AE4 is also a protection input, so which makes 3 of these. That's protection input. And then I think we've got the powder switch, which is also a protection input. So we're talking about 4AE2, 4AE3, 4AE4, and then we've got the powder switch. Okay, and then I think we've also got the motor isolators. Okay, Vibro 1, motor 1 isolator, and Vibro 1, motor 2 isolator. So these are also part of the protection. Okay, so we need to go to the address range for protection. Okay, how many of these are there? So we've got 4AE2, so which is 1, 2, 3, 4, 5, 6 as protection inputs. Okay, 6, 6, 6, 7, 8, 9, 10, 11, 12. Okay, so all these 12 are basically protection inputs. I know I'm just counting them like this because I know the arrangement for vibrator number 1, this vibrator number 1, is pretty much identical to vibrator number 2. Okay, this is vibrator number 2. Okay, so the ones we've identified as protection inputs for vibrator number 1 to be the same thing for vibrator number 2. Okay, so if we count them, we're going to have like 4AE2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 protection inputs for both vibrator number 1 and vibrator number 2. Okay, so we need to go to the address range for protection inputs, so which is like 5.7. Now that's these outputs. What's that? Was the input range. Okay, we're here. Okay, so we're going to insert 12 of these inputs. So 1, 10, 11, 12. Okay, and maybe just one more for good measure. Okay, we don't want to make mistakes. I know we're going to delete this, but just a safety precaution. So 4AE2, so 4AE2 all the way to V2 M2 isolator. So vibro number 2, motor number 2 isolator up to here. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We need to copy these, and then we need to come and paste them here. Okay, like so. And then the only thing we need to add is just this peripheral input assignment. Okay, so that's the only thing we need to do. Okay, okay, like so. Then we can get rid of this because we don't need it. Okay, yes please. So now you see that we've pretty much taken care of the protection inputs for both vibros. The only other thing we need to look at is the vibrator 1 start, local, and remote. Okay, so vibrator number 1 stop, local, and remote. So those are just going to be like ordinary inputs. Okay, so let's go to the address range for ordinary inputs, which is like right about here. Okay, so we need how many of these? We need 4, right? think we need 4. So 2, 3, 4. Okay, because we're going to need the vibrator 1 local start, and then vibrator 1 remote start, then vibrator 1 local stop, vibrator 1 remote stop. So these are like 4 for just the first vibrator. Okay, we'll go to the range, the memory bit range for normal inputs. This was what? This was we're talking about 4AB7, 4AB7, 4AB7. So okay, here. Okay, so essentially we're talking about vibrator 1 local stop, vibrator 1 remote stop, vibrator 1 local start, vibrator 1 remote start, vibrator 2 local stop, vibrator 2 remote. So basically we need all of these here. Okay, so these are like 1, 2, 3, 4, 5, 6, 7, and 8 as normal input signals, right? So these are 8. So let's go to the address range for normal inputs. So this is 1, 2, 3, 4, and 8, right? So, and maybe one more just for precaution so that we don't overwrite anything. Okay, so we're talking about this range here. Okay, talking about this range of inputs. Okay, and then come here like so, and then of course we're going to copy the same symbolic comments. If we don't really have to, but I don't know, there's no harm. We could copy the same symbolic comments, okay, because it's pretty much the same thing. One range of addresses is just memory bit addressing, which we're using for configuring our logic. Okay, then this other range of addresses is for the actual physical input modules. Okay, and then this is just going to come in handy in the mapping. So this will say peripheral input. We're going to copy this and then make our way down the list so that we make everything right. Okay, so we've done away with the normal inputs, right? So we've done away with all the normal inputs. Okay, so what else do we need? I think we're pretty much okay. So the other thing now, to allow the Shapama output conditions, okay, such that vibrator number 1 on, vibrator number 1 4th strip. We don't really care much about this, or at least I think we don't, because it's basically internal control where the PLC is concerned. But the indicator lamps, we definitely need this. Okay, so what we're gonna do is what are we gonna do is this. So we're looking for 4AC1 on the output side of things, so memory bit 100 range. Okay, so go down the list, we look for memory bit 4AC1. So for outputs, essentially we're talking about this range of addresses. So we're talking about vibrator number 1 on, vibrator number 1 4th strip, vibrator number 1 4th strip indication, vibrator number 1 running, vibrator number 2 on, vibrator number 2 4th strip, vibrator number 2 4th strip indication, vibrator number 2 running, vibrator number 2 powder switch operated indication. Do we need this? Powder switch operated indication on outputs. Vibrator 2, where's vibrator number 1 powder switch over? Okay, so actually we're even going to need this for the operation of the powder switch. Okay, so this is actually a thing. So powder switch operated by external vibrator control, and then in the 2 indicator positions. So 1, 2, 3, 4 output conditions for each, a total of 8. Okay, for 2 vibrators. So let's see, what do we do with this information? What do we do with this information? Okay, 1 2 3 4 5 6 7 8 9 and 10. Okay, so these are going to be outputs. So let's insert 10 more output addresses. So 1 7 and 8. Okay, maybe let's end with 8. So where the outputs are concerned, our concern has to start with vibrator number 1, powder switch operated indication. So if we want this as a physical indicator lamp, we're going to need to have to assign it to a physical output module, right? And then of course we need 4AC1. This is 4AC1 for vibrator number 1 control. Okay, so we're going to come here. Oh, this is actually PO. Okay, then 4AC1 as PO, and then the other one we need is 4AH1 and 4AH2. So we need 4AH1 and 4H2. We need these two here. We need to place them right there. Of course, these are going to be peripheral outputs. Okay, like so. And then of course we need a similar range of addresses for vibrator number 2, which is to say would need vibrator number 2 powder switch operated indication, which is this one here. So peripheral output. Then of course we're going to need 4BC1. Okay, so 4BC1, if I'm not mistaken. 4BC1 is this one here as peripheral output. And then we're going to need 4BH1 and 4BH2. So we're going to need 4BH1, 4BH2. So 4BH1, 4BH2. Okay, I'm going to paste this here like so. Okay, no. So this is what we're going to have. So 1 2 3 4. 1 2 3 4. So we're good with this. So we've basically assigned all the outputs, and we've basically reassigned all the inputs. Okay, that's what we've managed to do. Let's see. So we're not going to confuse ourselves. So we 4 what 4 AB7 on the input side of things. 4 AB7. Ordinary inputs for so this range of, okay, so we're good. So now what we're going to do is now that we have this sorted out, okay, now that we have this sorted out, what we're going to do is we're going to do the mapping. Okay, so we're going to do the mapping. So we come to where it says input output mapping, which is this function here. Okay, so we're going to start with Hydroset. Okay, so we're going to start with the crash Hydroset control, where we just map the physical input output addresses to the memory bit addresses. Okay, so to help us have a more structured approach to this, what we're going to do is we're going to insert a network, okay, so that we don't mess ourselves up. So insert network. Okay, set network, and then this title is going to be Hydroset mapping. Hydroset, maybe input mapping. Okay, and for the Hydroset, clearly we're going to say and. So like I said previously, we can pass the signal state of an input address to a memory bit address. Okay, so we're going to say and. Okay, so Hydroset pressure switch. I hope this works. Hydroset pressure switch. Okay, so, and of course I know this is going to be peripheral input. Okay, and then we're going to pass this to Hydroset pressure switch. Okay, which is a memory bit address. Okay, and then this takes care of this. Okay, and then we're going to go to Hydroset raise. Okay, so we're going to say and. So I hope I'll get this right. So Hydroset, how would I write this? Hydroset raise peripheral inputs. Okay, apparently not. Hydroset raise, no harm, set symbol. So Hydroset raise, why did I get it wrong? So and Hydroset raise peripheral input, but why are you refusing? Maybe, how about this? So I'm just curious as to why it couldn't work, because okay, so like that. So and Hydroset raise peripheral input will be assigned to Hydroset. We're assigned to Hydroset raise. Okay. Oh, apparently we're getting touchy-feely. Be assigned to this. Okay. And then of course Hydroset lower will be assigned to. One is a peripheral input address, which is passing its signal state to a memory bit address, which we're using in the logic design. Okay, so again we'll say hi, and I know it's the same structure, so I'm just going to copy this, and then I'm just going to say lower. Be passed on to, so will be passed on to Hydroset lower. Okay, like so. Like so. So we've done this one, we've done this one, we've done this one. Okay, and then of course what else do we need to do? The only other thing we need to do is these are normal inputs, but we can also do the protection inputs. Okay, so we can basically just say insert network, and then we can say Hydroset protection. Okay, Hydroset protection input mapping. Okay, and then with that comes the, and if I say for AE3, okay, peripheral input, again apparently I need to put this in commas, again inverted commas if you want. So this is going to be equal to just for AE3. Okay. This is going to be assigned to for AE3. Okay, and then we've done for AE3. So the only other thing we need to do is for CE. what is this now? This is 4. This is 4CE3. 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 Okay, so this is 4CE3, and then this is going to be 4CE3. Okay, which is fine. So we've done 4CE3. Now we need to do 4CE2. Okay, so we can just as well copy this to be faster. Okay, so this is becoming 4CE2, and then this is 4CE2. Okay, like so. So we've done 4CE3, 4CE2, 4CE3. We don't need to worry about 4CD1. It's just a saline contact for this coil, okay, or relay if you want. Then 4CH1, then 4CH2. Okay, so we're talking about protection input. So this is a protection input, and what else? The Hydroset pressure switch was actually declared as a protection input. Huh? Is it? Yes, I think so. So this wasn't supposed to be here. This is a protection input. Okay, this is supposed to be protection input. Okay, so 5, 6, and 7. Okay, I haven't changed anything. I've just rearranged because the Hydroset pressure switch associated input is a protection input. Okay, so this is a protection input, protection input, protection input. So we've actually got like 3 protection inputs. Okay, and then moving forward, the only other thing is as an ordinary input, the alarm cancel. Okay, alarm cancel. Okay, so we have AND. I don't remember what the alarm cancel was, so there's no shame in just checking. Okay, alarm cancel, Hydroset alarm cancel, Hydroset alarm cancel. Okay, Hydroset alarm cancel. Okay, so apparently it's this one. So Hydroset alarm cancel, we need to pass our signal state to this one, so I know it's got an associated peripheral input. That's odd. Let's see, where did we go wrong? Options, symbol table. Okay, Hydroset alarm cancel. Hydroset alarm cancel. Let's see. For the Hydroset should be under normal inputs. So the normal input range is this range. Okay. Let's see. H. Where did we talk about the Hydroset? Where did this become an issue? So Hydroset. Come on, let's see. Where are you? Okay, so I've got this Hydroset alarm cancel, alarm active. This was an output, but on the input side of things, what did we have on the input side of things? Hydroset alarm cancel. I don't think this one was mapped. Okay. And then this other one, what are we saying? So Hydroset alarm cancel, active, and then this other one is Hydroset alarm cancel. So maybe let's do this. So Hydroset alarm cancel, HAC. Okay, and then of course apparently this hasn't been mapped. and it's a normal input signal. Okay, so we need to go to the address range for normal input. So we ended at input 3.5. so we need to have Hydroset alarm cancel as a peripheral input. Okay, that takes care of that. So we have Hydroset alarm cancel. Hydroset alarm cancel. Okay. Apparently doesn't want to come out and play. But why? Okay. Hydroset alarm cancel is a peripheral input. This is a 5. No wonder. Options. Symbol table. Apparently I can't tell the difference between Hydroset alarm cancel peripheral input. What is this I'm seeing? Hydroset H5A. Should be very sleepy. Should be very, very sleepy. So let's see, Hydroset alarm cancel as a peripheral input. Hydroset alarm cancel. Need this one here. And then of course it's going to pass its signal state to Hydroset alarm cancel. Okay. Like so. That takes care of the toggle switch if you want. Okay. Then Hydroset low pressure siren. Did we assign that? Options symbol table. Let's see, Hydroset low pressure siren on the output side of things. We talk about the Hydroset for reset should be on the output side. Okay, output side. Hydroset low pressure siren. Hydroset low pressure siren. HLPS, which is this one here. Do we have HLPS mapped to a physical output? Apparently not. Okay, so we need this set symbol. Okay, then this just peripheral output. So what do we have here? Okay, so Hydroset alarm cancel is a normal system input, this one here. Okay, and then of course we're not talking about the solenoid valve because we haven't come to the part where we're talking about outputs. Okay, so moving forward, we've done 4CH. No, these are outputs, not yet. So to recap, we've done the Hydroset pressure switch, which is a protection input. Okay, and then we've also done the thermal overload, and then we've done the earth leakage for 4CE3 and 4CE2. We've done 4CE3 and we've done 4CE2. So these are taken care of, and those are the only protection inputs. Normal system inputs, Hydroset input mapping, those are just normal inputs. So we've got the Hydroset raise. Okay, so Hydroset raise, and then we've got the Hydroset lower, which is Hydroset lower, and then we've got Hydroset alarm cancel. Okay, so Hydroset alarm cancel is this toggle switch here. Okay, so that takes care of that. And then the only other thing we need to do is insert network, and then we can copy most of these so that and then Hydroset output mapping. Okay, so this is going to be output mapping, and then for the output mapping, the physical outputs to be controlled, we're talking about 4cc1, 4cc2 just for a start, okay? And then we can pass the state of a memory bit address, okay? We can pass the state of a memory bit address to a physical output address, which is again 4cc1. I think that was PI. 4cc1, no, 4cc1 PO, I think, okay? And then we can do the same thing for 4cc2. I know, can just copy this because I've maintained more like a similar naming convention, so I can just rename this to 4cc2, and then of course I can also rename this to 4cc2, like so, and then everything, the addresses are changed like that, okay? So we've taken care of 4cc1, 4cc2, and then of course the only other physical outputs will be the indicator lamps, okay? So we're talking about the indicator lamps, or maybe let's deal with the solenoid valve control, okay? So what we're going to do is and okay, SVC will be passed on to SVC PO, okay? So we've taken care of the SVC, the solenoid valve control, and then we can talk about the indicator lamps, okay? For the indicator lamps, we're saying and 4CH1, okay? And 4CH1, not 4Chi, but 4CH1, and 4CH1 will be passed on to 4CH1 PO, okay? Like so. The same thing for 4CH2, so maybe we just copy this and then paste there to 4CH2 and then 4CH2, okay? So we've taken care of 4CH1, we've taken care of 4CH2, and then we've taken care of the solenoid valve control, okay? And then hydroset pressure, okay, did we map this? So hydroset pressure, so options symbol table, because I'm not so sure. So hydroset pressure, okay, or hydroset pressure fault. So when we're talking about the hydroset, let's see. The hydroset HDR, meaning we're talking about these two. Hydroset okay, indication, and hydroset fault. Essentially we're talking about these two indicator lamps, okay? And then of course we are talking about hydroset low pressure siren, but okay, let's see. On the output side of things, we need this, okay? So we need these two assignments, okay? So we need these two to be assigned to outputs, okay? So this is PO, and then of course that is PO, right? And of course this is 7.2, and now we do the mapping, okay? So we say we've done CH1, we've done CH2, and then HDR okay, and then HDR fault, okay? So what we need is and we're saying HDR okay is being passed to HDR okay as a peripheral output, okay? Hope hopefully I didn't write peripheral. Okay, so that's fine. And then we also need and HDR fault, being passed on to HDR fault peripheral output. Okay, like so. So I've taken care of these two indicator lamps, HDR okay, HDR fault, and then Hydroset low pressure siren, okay, which is this one here, the Hydroset low pressure siren. So and I think that superseded these two. Okay, so and Hydroset low pressure siren, okay, will be passed on to the Hydroset low pressure siren as a peripheral output. Okay, like so. So we've taken care of the everything here. Hydroset low pressure siren, Hydroset fault, Hydroset okay, the solenoid valve has been mapped, and then I think those are the physical outputs that we needed to map. Then we can move on to the vibrators. Okay, these are crusher vibrator. Okay, so again we can just go through the same motion. Okay, so we can just say vibrator number 1. Okay, so vibrator number 1. So what do we have to say about you? Okay, so we say input mapping, knowing very well that we're talking about normal inputs, not protection inputs. Okay, so we have these. So what do we have to say for ourselves? If you wanted to simplify our lives so much, because this can take forever. Okay, so option symbol table, because these were sequential. I think when we're talking about 4AB7, so let's find where 4AB7 was in this madness of ours. Okay, so vibrator number 1, local stop, remote stop, local start, remote start, local stop, remote stop, local start. Okay, so effectively we're talking about all these inputs. Okay, we're talking about all these inputs. Oh, we might as well start from here. Okay, so we're going to be needing all of these. Okay, we're going to be needing all of these. Maybe let me just copy everything up to the feedback. I know I'm going to separate these into vibrator number 1 and vibrator number 2, but I just need them to be in the same place. Okay, don't worry about this. It may look like some madness or something, but I just want to simplify things. So this is what we have. Okay, so vibrator number 1 select or vibrator number 2 select. So we know very well that the B's are for vibrator number 2. Okay, so we know that the B's are for vibrator number 2. And then of course vibrator number 1 feedback is here. Set network and I know I'm going to be needing these for, when the time comes, we're going to be needing these for vibrator number 2. But right now we're talking about vibrator number 1 input mapping. So these are just normal inputs, right? And then we need to think about how we're going to classify. Nope, I think the feedback will just be a normal input, just to simplify our existence. Okay, so now comes the interesting bit, that these bits, vibrator number 1 select, did we map these to physical inputs? Okay, vibrator number 1 select, normal inputs. Let's see, normal inputs, vibrator number 1 select. Oh, let's see. So vibrator number 1 select, vibrator number 2 select. I don't think these two were mapped to physical output addresses. Okay, so maybe we need to correct this oversight. Okay, so essentially what we're saying is we need vibrator number 1 select, and then we need vibrator number 2 select. So these are going to be peripheral inputs. Okay, these are going to be peripheral inputs, like so. Okay, so when this is done, the only thing we need now is to proceed. Okay, okay, so we're saying and vibrator number 1 as select as a peripheral input, because I know it's the same symbolic names. Okay, the same everything. So I'm going to copy this. I'm going to say this is going to be assigned to, it's going to be assigned to this address. Oh, come on. And then of course for AB7. Okay, I know what we have is this, that and then of course I know, of course we did talk about peripheral inputs, but this is going to be passed to this guy, this address. Okay, AB0 no space, and then of course we know, okay, I'm going to copy this, and then I'm just going to say and as a peripheral input is going to be assigned to this address. Then I'm going to copy this, then I'm going to say and then I'm going to say peripheral input is going to be assigned to this here. Then I'm going to copy this, and I'm going to say and is equal to I need to add peripheral input to this address. Okay, like so. And then of course lastly we've got the feedback. So I'm just going to copy this, then I'm going to say and if we've mapped this, it shouldn't be a problem. Okay. Currently we haven't mapped that, so we're going to take care of that. Okay. And then of course, simple table. So we're saying v1fb, okay, feedback. Okay, so we're talking about this address here. We need to have it mapped to a physical input address. So we need two of these. So insert symbol, and then I need v1fb and v2fb. So this is vibrator number 1, power contactor feedback, vibrator number 2, power contactor feedback. So I need to paste them there, and then of course these are going to be peripheral inputs, okay, like so. Okay, so that takes care of that little problem. And then now that we have this taken care of, these are just the normal inputs. So if you could see the symbolic comments here. So we're talking about local stop, okay, local stop for vibrator number 1, remote stop for vibrator number 1, then local start for vibrator number 1, and then remote start for vibrator number 1, okay. And then the feedback, okay, vibrator number 1, power contactor feedback. So we've taken care of basically all the normal inputs, okay. So we're going to insert network, and then of course we're still talking about vibrator number 1, except now we're talking about protection input, okay. So what we're going to do is what? Maybe it's better we copy everything to do with vibrator number 1 all the way up to here. Okay, this is vibrator number 1. Okay, so let's copy this, okay, as protection input. So we have Control V. Again, I know that Control C and Control V. These are peripheral inputs. Be assigned to that address, okay. So and this address is going to be passed, the signal state of that is going to be passed to the memory bit address, okay. Then of course we move on to this to say and. There's a peripheral address, will be passed, the signal state of that will be passed to this, okay. Part012 switch, vibrator 1 part012 switch. So saying and Control C. Hopefully we've mapped this one. Okay, so the signal state of that we pass to that. Then here again and vibrator 1. So say PI. The signal state will be passed to a memory bit address. Okay, so pass to a memory bit address, and then of course this one, and then of course peripheral input. We're going to pass this signal state to the memory bit address. Okay. Memory bit address like so. Okay. Inside network, we're still on about vibrator number 1. Okay. Still on about vibrator number 1, but now we're talking about output. Okay. Talking about output mapping. Okay. And then for vibrator number 1, so when we talk about outputs, what are we talking about? So we're talking about 4AC1, 4AH1, okay, Part012 switch operated, Part012 switch operated. Okay, maybe let's do it like this. So we're saying, and if we want it, I think the symbolic table is still our best bet. Okay, so the output range for vibrator number 1, output range, so we're talking about 4AC1, 4AD1, 4H1, 4H2, and Part012 switch operated. Okay, so essentially we're talking about this range. So we're talking about, okay, I'll take everything, then delete what we don't need. Okay, so bear in mind that now we're talking about outputs. Okay, so I'll do this. Okay, then having done this, I know that the B's are for vibrator number 2, so I'm going to get rid of this, and then we'll deal with this later. Okay, so 1 2 3 4 5, 1 2 3 4 5. Okay, so what it is now is this. Okay, these are memory bit addresses. So a memory bit address can pass its signal state to a physical output address. Okay, so which is to say, this now will pass its signal state to peripheral output address. Okay, the same thing goes for this here address. It's going to pass its signal state to a physical output address. Okay, which is a peripheral output according to us. We keep saying peripheral output. Okay, like so. The same thing goes for this memory bit address. We require for it to pass the signal state to peripheral output address. Okay, what do we have here? 481. What's your problem? 481. No, 481 wasn't a physical output. We don't need this one. We don't need 481, but because 481 is purely going to be used just internally for logic configuration within the PLC, and it has nothing to do with external load control. Did we not say something about 481? Anyway, we'll deal with that if it's needed, but I don't really think it's needed to control anything externally. Okay, So we have this, then this is of course going to be a peripheral output. Okay, and then of course we have this one here, the memory bit address passing the signal state to the peripheral output address. Okay, like so. So we've got the Part012 switch operated, which is already mapped to this output, and then we've got the vibrator number 1 control by way of 4AC1, which is also mapped. We're talking about 4H1 and 4H2, okay, which are also mapped here. Okay, so now clearly vibrator number 1 has been fully mapped. Okay, so it's been fully mapped. Now also, okay, I'm just going to try something here now, because we're using more like similar symbolic names. Okay, because we're using similar symbolic names, if I copied this here, okay, which is normal input mapping, okay, I'm just trying this out, see if it could actually work. Okay, so I'll do this, then I'll say this is vibrator number 2, okay, because I know we've used similar addressing. Okay, so this is 2, and then I know for vibrator number 2 these are just B's. Okay, the A is replaced by a B, like so. Like so. Then of course this here becomes 2. Then this of course becomes 2. Okay, so okay, this seems to work. So vibrator number 2 input mapping. Okay, so I've done vibrator number 1 input mapping, so vibrator number 2 protection input mapping. Okay, so we're going to copy this, then we're going to paste it there, and then of course this becomes vibrator number 2. Okay, protection input mapping, and as always, where there's an A, we put a B there. We're right in doing this protection input mapping. So again, this is B. So this is B. B there, and wherever there's an A, we put a B. Okay, wherever there's a 1, we put a 2. Okay, so that takes care of the vibrator number 2 protection input mapping. Okay, so we've done the protection. Where was this thing now? So vibrator number 1 input mapping, vibrator number 1 protection input mapping, and then vibrator number, no, this is just output mapping. There's no such thing as protection output. So this is vibrator number 1 output mapping, but we also need to map outputs for vibrator number 2. So this is going to be vibrator number 2 output mapping. So we just need to change where there's a 1, we put a 2 there. Okay, and then of course this is a B. Okay, so basically this also takes care of the vibrator number 2 output mapping. So now the only thing, we don't need this because of the way we are naming the inputs and the outputs. It was more like a uniform way of naming them, so it's easy to edit them like that. Okay, so this takes care of the mapping. We've pretty much taken care of the mapping of the inputs and the outputs for both the Hydroset and the vibrators. So hopefully this has been helpful, and I'll see you in the next run. Okay, ciao.